Now let's just move on further towards the third type of method, which is called as the step deviation method. So there are basically two steps that are involved over here. So what are those steps? The very first step would be like we have to calculate ui, which is nothing but is equal to xi minus of a divided by h. So as you can see, this is nothing but a division of the deviation with respect to the h, where h is representing the class size. So ui is nothing but is equal to xi minus of a divided by h, where a is the assumed mean and h is nothing but the class size. And then the next step would be like we have to calculate the mean using the formula x bar is equal to a plus of h sigma of fi ui divided by sigma of fi. So it is actually just same as that of the assumed mean method, but here we are just taking a further step, means we are, rather than taking a deviation di, we are using ui over here, and we are also taking a product of this particular ratio with the h. H is representing the class size. So let's just see how we can apply the step deviation method in the previous example that we have already taken. So let us suppose if I'm just taking that previous example again. So let us suppose if this is my table, so you just have to neglect the other tables. First of all, we are just concentrating on these two only. So here I have just represented the number of the students as only fi, so I'm using just a simple fi over here. You already know that these are nothing but the number of the students. This is my class interval, this is my number of students, and now again I'm finding out the xi was nothing but the class marks. So in all the three cases we have to find out the class mark. So class mark is actually a necessity for us. So in all the three cases we have to calculate the class mark. So it is quite now important that we have to calculate the class mark in all the three cases. So remember this concept. Now further, for the next table we have to calculate the deviations, which is di, which is nothing but xi minus of a. So you can see in the next table we have to calculate deviation. So we have already calculated the deviations in the assumed mean method. We already know about this concept that we have to look out for the assumed mean, and assumed mean is actually the value which is in the center of all the xi's. So here we are again taking the assumed mean as nothing but 47.5. We already know about this because we have already done it into the assumed mean method. So here I'm just taking the difference of xi's with the 47.5. So when I'm just taking a difference, we are getting all these values over here. We already know that all these values that we are getting by taking a difference of xi with 47.5. Now again, the next table is actually different from the previous two methods. This table is actually representing a division of xi minus of a with respect to h. So basically we are taking this as, let us suppose if I'll rewrite it, this is nothing but xi minus of a whole divided by h, So let's just see all by yourself that this is actually nothing but xi minus 47.5, which is nothing but minus 30 divided by h. What is h? H is nothing but the size of the class. How we can find the size of the class? So as you can see, h is nothing but the size of the class, and we can calculate the size of the class by taking the difference of the upper class limit and the lower class limit. So this is nothing but the upper limit minus the lower limit. So let's just take any particular limit. So let us suppose if I'm taking the very first, this is 25 minus of 10, and we are getting the answer as nothing but is equal to 15. So hence the class size is nothing but 15. So let's just take a difference. So for the very first u1, we can say u1 is equal to x1 minus of a by h. We know that x1 minus of a is nothing but minus of 30 divided by h means 15. So the answer is nothing but 2. So this is nothing but minus 2. So you can see over here all by yourself that this is nothing but representing division of minus 30 with respect to 15. Moreover, again, this is actually representing minus 15 divided by 15. Further, this is representing nothing but this is representing 0 by 15, and which is again 0. This is again representing 15 by 15, which is nothing but 1. This is representing 30 by 15, and this is nothing but representing 45 by 15, which is nothing but 3. And in the next table, we have to take the product of the frequencies is with the UIs. So this table is FI, UI. You can see all by yourself. You can take the product of FIs with respect to UI. You can take the answer as, you can write this as nothing but 2 into minus 2 is actually nothing but is equal to minus 4. Further we have minus 1 into 3 is nothing but minus 1 into 3 is nothing but minus of 3. Further we have this as 0 into 7 which is nothing but 0. Further we can see over here this is 6 into 1. Further this is nothing but 6 into 2. You can see all by yourself that we are taking the product of this term with respect to this term, 6 into 2 which is nothing but 12. Further we are taking the product of 3 into 6 which is nothing but is equal to 18, and let's just take the sum of all these, which is nothing but representing the sigma of Fi UI, which is nothing but is equal to 29, and the sigma of Fi is nothing but is equal to 30. So let us suppose if I'm recalling the formula again. So that was the formula for the step deviation method. X bar is equal to A plus H sigma Fi UI by sigma Fi. So let's just plug in all the values in this formula and we will get the answer. And many a times, let us suppose if I'll write it over here, many a times we also write it as A plus H U bar, where actually U bar is representing sigma Fi UI by sigma Fi. So we can also write this formula as of this form. So let us suppose if I'm just calculating the mean over here. So X bar is nothing but is equal to A. What is the value of A? A is 47.5 plus of H. H is nothing but 15. So this is 15 into sigma Fi UI. This is 29 divided by 30. This is 29 divided by 30. So this is 15 and 2. So let us suppose if I'm just further calculating it, this is 47.5 plus of 29 by 2. Let's just sort it out. 29 by 2 is nothing but 4.5. So this is 14.5, and when we will just take the sum of it, the answer is coming out to be equal to 62. So hence it implies that at the end we are again getting the mean as nothing but is equal to 62 using the step deviation method. So you have already seen in the previous two methods that the answer for the similar question was actually coming out to be is equal to 62, and again in the step deviation method the answer for this particular question is again coming out to be the same as nothing but is equal to 62. So this is all about the step deviation method, in which you have to calculate in which you have to form the two extra tables. Means you have to form a table of UI, which is nothing but Xi minus A by H, and then you have to form a table of Fi UI, and then using this particular formula you can able to calculate the mean using the step deviation method.